Okay, let's get started. We're starting right on time. This session is about Node.js on Azure. This could have been a session about Python or any other open source technology on Azure. I picked Node.js basically because I already know a little bit of JavaScript, and Node.js literally is everywhere, right? So developers know JavaScript. If you know JavaScript, the step to server-side JavaScript is very very small. Who of you have ever developed something in Node.js? All right, 2, 3, 4, 5. The nice thing is, so Node.js is JavaScript on the server side. So historically, JavaScript is in the browser. Node.js took the V8 JavaScript engine and made it available on the server itself. So you can write server-side code and client-side code, both in JavaScript. The nice thing is with NoSQL, we also see that data structures like JSON and NoSQL databases are becoming more and more popular. So you have complete stacks that are based on JavaScript. You don't have to make the switch in your head. So that's why it's really catching on, I think. Another thing is that Node.js has this concept of evented I/O. So when you look at synchronous I/O, a request comes in, and the request will be a thread will be spun up, and within the lifetime of that thread, the request will be handled. Now we can bring in some asynchronicity, so we can spin up multiple threads, right? And that will work pretty performant. But we will be using a lot of resources. Every thread will require a certain amount of RAM, a certain amount of memory. Evented I/O will take the request that's coming in, and it'll put it on a thread as well, but it will be available for other requests after that. So it will continue, and it will wait until it gets a callback from the other threads that will do I/O options, for instance. So it's really fast with a really small resource footprint. That makes it super interesting for cloud computing, right? Because in cloud computing, we're paying for the resources we're using, and cloud computing, typically, we like to scale out instead of scale up. We want to have multiple instances instead of bigger instances. We want to have multiple servers doing the same thing, but small servers, instead of 1 or 2 big servers doing a lot of things. So I'm not going to give you a history lesson on Node.js here, but the thing I want to point out here is that as soon as 2011, we picked up on this, right? We saw the potential of Node.js, and we made it available in our platform as a service offering called Web Apps. Websites at the time, and now it's called Web Apps. We invested heavily in making Node.js available in every service that we offer. So every service that comes out right now, like functions, like API apps, you name it, it'll have Node.js as a language that you can use to program in. So I mentioned already the app service, or the web app. Web app is part of app service. Who of you have worked with app service? 1, great, because 2. So let me explain a little bit what app service is. When you're developing an application, you're not an infrastructure guy. You're not the most capable person for maintaining servers, maintaining networks, and load balancers and stuff. That's where we come in. Let us take care of that infrastructure, right? And Azure App Service is a service that will take care of the underlying infrastructure, and you can just focus on your application. Now we have several flavors in Azure App Service. We have mobile apps, functions, logic apps, API apps, and eventually also web apps. So mobile apps have their own characteristics, right? Mobile apps need to be able to synchronize offline. They need to be able to cache offline data, and when they have connectivity, they need to sync that with the backend in the cloud. So we have specific APIs for that, and we call that mobile apps. APIs have their specific implementation. So it's all, an API is also a web app, right? But it has some specific things like a Swagger definition, an API definition that gets generated automatically, API authentication built in, right? So these are features that are built in in the API apps offering that we have, and you can use API apps for that. Functions is the serverless offering that we have. How many of you have heard of serverless? Okay, so with serverless, you just pay for the seconds or microseconds that your code is actually running, right? So you don't have to pay for a server underneath. You don't pay by the hour. You pay for the seconds that your code is run, and after that, you don't pay anything. So this is really interesting when we're talking about event-driven architectures. Then there's logic apps. If we're looking at the functions and the mobile apps and the API apps, maybe we want to tie them together. We want to be able to receive an event from a file being uploaded, for instance, or an email being sent, and that event needs to trigger a push notification to mobile applications, for instance. That can be done with logic apps. So with logic apps, without writing a single line of code, you can tie together all these independent components and have them interact together in an intelligent way. Finally, there are web apps. And I'm going to dive a little bit deeper in web apps. So like I said, API apps and mobile apps are actually web apps. So they work exactly the same, but they have some specific characteristics. But the concepts I'm going to explain with web apps applies to those two as well. Azure App Service, first of all, there's this notion of app service plan. So you need to create an app service plan before you can create web apps. What is an app service plan? First of all, an app service plan is a virtual machine. You can look at it as a virtual machine. You define a size, and it'll run for you in the backend. We will take care of the network connectivity. We will take care of the load balancer, everything. You can scale it up, so you can assign a different SKU to this app service plan and make it bigger. Assign more RAM, more cores to it. You can also scale it out. So you can automatically scale out your instances and have multiple of them running side by side. And you can host multiple web apps on a single service plan, or you can host a single service plan, a single web app on a single service plan. So what are web apps? We know web apps as code, right? But what are web apps in Azure? Well, first of all, it's like a container for configuration. And I quoted container because this is not a Docker container or anything like that. This is just a fixed set of configuration that you can make that will be the same every time. Then it's an execution environment for your code. You can have multiple deployment slots, right? So you don't have to delete your previous deployment before you have smoke tested your new deployment, for instance. So that means that it supports blue-green deployments. It also supports A/B testing. And it has advanced monitoring included, and lots more, right? I'm not going to cover everything. I have 45 minutes in total, so. But the key part is it doesn't only run .NET. It runs all sorts of open source applications as well. So it has a Python runtime. It has a Java web service with Tomcat and Jetty. It has PHP support. And obviously also Node.js support, and it is extensible. So if you want, you can deploy your Go applications here as well. So let me do a demo of app service. In order to give you this demo, I'm going to create an app service real quick, right? So I go to the portal, portal.azure.com. I click new and I search for web app. I click the web app, hit create, and I'll give it a name. The name doesn't exist yet. So it'll create a new resource group for me. With a resource group I can manage multiple resources together. I can also specify an existing resource group if I want. And I can specify an app service plan. I can create a new app service plan for this. TD Node demo plan. And I want this in West Europe, which is Amsterdam. And then I can specify a pricing tier. Right? And pricing tiers define how many cores, how many RAM will be in the virtual machine, but also some additional features like SSL support and those types of things. I'll just keep this to the default of S1. Hit OK. And pin it to the dashboard and create. Can everyone read this? So this will take a couple of seconds to create. So first of all, this will create a resource group, which is this one. And it'll start creating the plan, as you can see right there. And when it created the plan, it'll create the web app. So this isn't refreshed yet, but it'll create the web app. And I can go into the web app, and now we have our running environment, right? But I don't have my code there yet. So first of all, I told you this is a container for configuration. So let's show you what I can configure. I can configure a lot of things. I can't go through everything. But first of all, I can look at the application settings. And as you can see, we have PHP here, we have Java here. We can specify those independently. I can set always on. I can define whether I want sticky sessions or not. So session affinity. As you can see, it has this app setting. Let me enlarge this a little bit. It has this app setting called website Node default version. So it by default has a number of versions of Node installed on the machine, and you can select a version. So you can type in a version and you can change the version if you like. I'll keep this to the default, and I'll save this. I can set up backups. I can integrate authentication. I can set up my SSL certificates. Everything you are accustomed to doing on a server, but we'll take off the difficult parts for you. Okay, so now I want to deploy some code here, right? So first of all, I need to have a Git repository. So I can specify some deployment options here. And I can choose a source, and I have the choice of various sources. So I can choose Visual Studio Team Services, even Dropbox and OneDrive. But for this one, I will create a local Git repository. I'm not going to do the performance test because then the performance test will go on for a couple of minutes, and we don't have the time. But you have the option to upload performance test, and with every deployment, it'll execute the performance test as well. So now it will create a Git repository on the actual server, on the app service plan in Azure for me. And if I go down to properties, there's the Git URL. There's the Git URL, right? If I copy that, I can connect to this from my remote machine. So I just copy this. Okay. So now I need to write my application. So for that, I'm opening up my Ubuntu Bash on Windows. I decided today I'm not going to use any Windows related stuff. So I'm using Chrome, I'm using Bash. And in Bash, I created a simple Express application. Express is a framework for Node.js to create like an MVC framework. So I can go in here. I could just show you what's in there. It's really simple. I can do an npm start. And it will start this application. And just to show you what it looks like. It is what it says it is. It is simple Express, right? This is really simple. Okay. So let me stop this for a minute. So now we want to make some changes to this application. Now, we have a full-fledged integrated development environment called Visual Studio. We also have a very lightweight one, which is more favorable with open source developers, called Visual Studio Code. From within the Ubuntu Bash, I can open up Visual Studio Code on this location. And as you can see, it opens up my files and my folders and everything in my application in this environment. And I can start making changes here. So I can start by changing some views. So I can say, well, this will be welcome TechDays. How many welcome TechDays did you see today? A lot? Yeah. Name says this app is running on host. Right? Now this is my model, right? I need to supply the values for this. So this is my backend, my controller, so to speak. So I can say var name equals. So what is your name, sir? You look trustworthy. What's your name? Alexander? And I'll like so? Yeah. And just to show you I have no tricks up my sleeve, I will do host.os.hostname. I need to import the OS. There we go. So I made some changes to my application and I want to make sure that this works before I deploy it to anywhere. So I want to debug this, right? The nice thing from Visual Studio Code, now it's running on Windows, but it can also run on the Mac, can run on Linux. It'll just work, right? And that's why I showed you this way. So I can start debugging this. So I can go to the debug portion of this website and I can just start this application. And the nice thing is, it doesn't know what application it is. It lets me choose for an application, a launch configuration. And I can pick Node.js, but I can pick Go or Python or .NET Core. Oops. And I'll just pick Node.js for this. And this will start my debugger. Let's add a breakpoint as well. Oops. And let's refresh this page. Right now, my breakpoint is being hit, and I can see the actual value, the locals of this current debugging session. I can also add watches. So if I wanna have them here, I can just say name, and it'll fill in the name, right? And this works a lot like any IDE that you're accustomed to. I can continue. And apparently I made a mistake, right? So that's good. I forgot to actually provide this the values to my model. Let's do this again. And my breakpoint is working. There we go. Right, so Alexander says that this app is running on Patriek van Dorp. That's the name of my machine. So trust Alexander, don't trust me. Okay, so let's stop. Now we have our application the way we want. Now we want to push it to Azure because we created this web app and we want to have our code over there, right? So I can use the terminal here to add this web app to my Git repository. So I can say git status, just okay. cd code demo. Simple express. Git status. I need to initialize a new repo. And now I see in my Visual Studio Code, I can see that there are some changes against the rest of my Git repo. So I can review my changes and I can add a message to this. I can say initial commit because that's what most people say with their first commit. If you know the Git flow a little bit, then normally I would have to add my changes first and then commit them. That's what this message says. Do you want to add them and commit them in one go? I can say yes or always, and then it will remember it. So that's good. It's now in my Git repo locally on my machine, and I want it in my Git repo in Azure. So all I have to do is I have to add a remote, git remote add Azure. I don't have it under my, so let's copy it again. There we go. And I can do a git push Azure master. And this will ask me for my password. And this will start pushing out my changes. And these are the differences. This will not be everything. And it'll start doing stuff. So it'll start doing an npm install. For those of you who don't know Node.js, you can have dependencies. Dependencies are listed in a package.json file. npm install will bring in all the dependencies from internet. So this will take a little bit of time. But at the same time, if I look at my deployment options in the website, you can see that a new deployment has been started for initial commit. That's my commit. Right? And in just a couple of seconds, this will. Oh, this will work. This will take a little bit of time. So for the sake of time, let's not wait for this. Let's go to the slides, and when I finish the last couple of slides, then I'll come back to this. It'll be finished. Okay. So I don't know about you guys. This is great that we can do this, but in a production environment, this is probably not what you want to do, right? You don't want your developers to push to a production environment continuously, right? So this is where the never-ending cycle of DevOps comes in. This is what we are accustomed to doing with production environments, right? We plan our work, we plan our sprints. Everyone is working agile, right? We plan our sprints, we develop it, and we go through all this life cycle, and we have several stages, several release stages, and several stakeholders that will have to sign off on that before it gets deployed. So, like I said, we have like a planning stage. You have to have like a sprint planning tool. You have to be able to track your progress. Then you have to develop it. So you need to have tools to develop it. Well, we just saw Visual Studio Code, so that's great. We saw Git, but you have to have a tool that builds your application, that will run the unit tests, that will do version control, and then we will have something that will take care of the release, right? When will it deploy to dev? And when it's on dev, who will decide when it's promoted to acceptance, for instance? And what are the criteria before it goes to production, actually? Most importantly, cloud load testing. You want to load test your application, right? The cloud offers a huge opportunity to bombard your application with requests from various locations all over the globe. And you can test it. This is a huge infrastructure if you need to set this up yourself. But you will only know the value of the features that you implemented in your application when you monitor your application, the usage of your application. Who is using your application? Who is using your new features? Where are the bugs? What are the slow pages on your application? And how many requests per day or per second are you getting for that page, right? So this is a really important step that is vastly overlooked. Okay, so I have a demo. We have Visual Studio Team Services, which is a complete offering that offers you all of this. The nice thing about this is you can use what you want. You can use it all, and I'm going to show you how to do that. But you can pick and choose things you want. If you want to use Jira for planning your work, that's fine. You can use Jira for planning your work. If you want to use Jenkins for building your code, that's fine. We can hook into Jenkins. As you can see, we are using some of those things as well in the demo. So first of all, let's see how far my app. So the application is ready. Now let me look at the application here. I can browse it. And the first time it needs to warm up. From the look of it, there it is. So now Alexander says that it runs on RD00 something, right? This is the typical naming of virtual machines managed by Microsoft in Azure. RD stands for Red Dog, which was Azure's initial name. So this is the application over there. Okay, so now we need all of this tooling, and I don't know if any of you have ever set up this whole release management pipeline before, but this can take weeks, if not months, right, to do this right. So what do? Well, you assemble the team. You say, yo team. And you give them some instructions. So what team are you talking about? Well, I'm talking about my team. Do you have permissions to talk to this team? Yes, I do. I have them here. So what do you want to use to build your code, right? I want to use a hosted service. I can create my own services, my own build agents, right? And they will be specific for me, and they will react instantly. If I do hosted, this is hosted infrastructure, hosted by Microsoft, and you will be placed. Your request will be placed in a queue, and it will be handled when there's enough time. So I will do hosted for this. What do you want to build? Do you want to build .NET Core, .NET Framework, Node.js, Java? Node.js sounds good. So what do you want to call your application? Well, call it TechDays Node and Demo. Where do you want to deploy it? So App Service also supports Docker containers. So if you want, you can deploy this to App Service Docker containers on Linux. You can even deploy it to Azure Container Instances, which is also charged by the second, and you can deploy your application there. But this presentation is about App Service, so I'll select App Service here. Now it's reaching out to Azure. It's getting some information back for me, and these are the subscriptions that I have permissions to, and I select the subscription that I want to use as my target. Do you want to install the dependencies? Do you want to do the npm install of Node? Yes, I do. Otherwise, my application won't work. And now it's going out to Visual Studio Team Services, and it will create a project for me, and all the steps that I talked about. So if I go to this page and just refresh it, not yet. Are there any questions so far? That's good. I'll repeat the question. Okay, so so the question is, how do you get from the Azure Web Apps to this where we are right now? So this is our release management tool that we can use, and this is the full DevOps lifecycle that I mentioned, and we do that with Visual Studio Team Services, and I'll show you how this will deploy the application to Azure in a minute, and you'll get exactly the same as I had before. Thank you for the question. So right now it has created the project, so I can look over here. And as you can see, it created the TechDays Node demo project. I can open this up. Let me just do this. This is better, I think. So you can see there's no code yet, right? And the generation of this application is taking a little bit longer because it'll create like a sample application for me as well. So it'll do the npm install and that sort of thing locally on my machine. And when it's done, I need to push it to here. So we have an environment to manage your sprints, right? So I can create a backlog. I can create features. I can say create UI, for instance. And to do this, I'll have to add tasks. And this task can be write HTML. And I can say save and close. I can drag this to a sprint, right? And I can define my sprint. When does it start? When does it end? Who are my team members and what's their availability in the week? If I fill in all those that information, I will get a burn down chart of my project. I can track the progress of the overall project. And we can go to the sprint board, for instance. So I can look at the Scrum board, and you can see that for the create UI backlog item, I have to write HTML. So I want to pick that up. I can say, well, this is in progress. and I want to assign this to myself. And if you're using the Git flow, you want to create a new branch for yourself to make the changes in, right? And the branch will be pushed to this repository, or there will be a pull request, and someone will merge that somewhere. So we can create a new branch as well, if we like. So we have this complete environment for you to use as well. Another thing is it has a build and release pipeline. And I don't think this is, yeah, it is finished. Oh, shoot. Okay. That's why I had a backup. This one. So it has a build definition. And this build definition will be triggered the moment you check in your code, and it will build your solution. So if we go to edit, I can show you what this looks like. So as you can see, there are several build steps here already defined for you. So get the sources, which obviously is something that's needed. Install Bower, run Bower. So it'll install the Bower application and run Bower to import all required JavaScript. It'll install for test. It will run the test, and it will publish the test results for you. It will also publish the code coverage of your unit tests, and then it will archive the files and put it in a repository, right? And when that's done, it will trigger a release. And this release will be done for a specific environment. So, for instance, a dev environment, right? And I can click on it, and you can get some details. So the first was succeeded. Pre-deployment approved, is pending for QA. I'm admin. Yes, yes. That's Yeoman. Exactly, exactly. So for those of you who don't know, I'm sorry, I skipped over that. Yo is a command from Yeoman, and Yeoman is a templating engine, right? So you can create applications, frameworks for it, but you can also do these types of things. So this makes it really easy to get started. Yes. Exactly, exactly. You can still use everything I did with Yo. You can do by hand. It'll just take you a little bit longer, because if you go and look at those definitions, so in the build definitions, you have to add all the steps, and you have to fill out the parameters. And again, these are default parameters. You can change them. There's no problem here, but you can. So here's the hosted agent, for instance, that I filled out during Yo. It will require the arguments here. So otherwise, I have to fill this out myself. So it's just easy this way. But oh, that's in the template. That's in the template. So if you a tip. Yeah. So Webpack will be defined in the package.json. And that will be dragged in. The package.json will have the required information of what steps need to be taken. So there will be a test script, for instance, in it. So that npm test will automatically test your application. Does that answer your question? No? That's in the template. That's in the template. That's something that we assume. And if there's no bower.json, it doesn't hurt. If there's a bower.json with the JavaScript dependencies, it will automatically run it. So unfortunately, my live demo failed, so I can't show you that it's deployed there, but I can show you the output of this. And because we, oh, come on. There. And again. This one. So what it created was three things. It created the app service plan, which is the top one. It created the web app, which is the bottom one. Right? We've seen those. And it created app insights. Application insights, and let me quickly show you this from an application that is running a little bit longer, because it's if it's an application that doesn't run that long, the information isn't that interesting. So here you get all sorts of information about resources that are consumed on the server, the requests that come in. If you add a little bit of JavaScript in your header of your application, it'll monitor client-side behaviors as well, and you can show your application map. You can look at the various components that are part of your application that we manage. So I have some automated tests here that will call an API. This is not a very sophisticated website, so this will not be very interesting, but it'll call an endpoint and it'll report on the response times and such. We can look at the metrics. We can do live metrics if configured right. We can look at the availability. So this is what comes from the tests, right? You can look at the failures, performance, the servers it runs on. If you have automatic scaling on, you can see that it scales automatically. So this could be really interesting. So I haven't implemented the actual JavaScript in this website. So the website itself, it's just the web app like I showed it before. Oh, okay. Oh. Okay, I have too many service plans in this in this subscription. Anyway. Upgrade, scale up. I don't know, what's the tier? Scale up. So this is how you scale up. And now I can browse the application. Anyway, so this is one environment. This is my dev environment. If I go into Visual Studio Team Services, my test department will have received an email with a link, and they can approve this this application. And then the next release will be triggered, and that will be a shorter release because it will it doesn't have to build. Right, because it'll take the output of the previous build from the repository again. So this is the app that Yeoman generates for us. It's a nice starting point. Okay, so wrapping up, everything I showed you in the portal can also be done from any command line. So we have our Azure CLI, which is available on Windows, on Linux, and on Mac. And you can do everything from there as well. You can script it if you like. It's really useful. So what's next? I've included some links. If you're interested, you can look at it. There are a ton of APIs that you can use. So from your Node application, there are APIs to manage Azure as well. I now talked about web apps, but also API apps and mobile apps in the backend can be done with Node.js. If you follow that link, you can find how that's done. There are some samples that I created that you can rebuild this whole thing, and you can start a free trial if you like. It's really important for me to get the right feedback. So if you are willing to take the time and go to the post-event feedback link and enter your feedback, that would be great. Thank you very much.